Hi everyone, welcome back to my Kubernetes Crash Course series. My name is Suraj Singh Rajput. I'm a DevOps engineer and a technical trainer. In our last video, we discussed about what is Kubernetes, what is the necessity of Kubernetes, and we saw the architecture of Kubernetes. And lastly, we created a Kubernetes cluster on an Ubuntu server by using Minikube. And in case if you have not seen that video, please go back and watch the video so that it will be helpful in this particular session. In this video, we will learn about how to deploy an Docker application on a Kubernetes pod, and we will learn about what advantages Kubernetes pods brings to the containerization. And following that, we will move on to what is Kubernetes deployment, how to create a Kubernetes deployment. We will go through this entirely on a practical note. And later on, we will go through what is Kubernetes service and what advantages that Kubernetes service offers compared to your Kubernetes deployment as well as pod. We will check in this particular video. Alright people, let's deep dive into our session where we will learn about Kubernetes pod. But the first thing is, so let me ask you a particular question. Imagine you have already created a Docker image from by using Docker methodologies, and you know how to run a Docker image into, or you already know how to containerize a Docker image. But why do we need Kubernetes? This we have already answered in our other sessions, but still try to understand in this way. See, when you deploy Docker image as a container, so we know that Docker containers are ephemeral in nature. That means they can crash or they might go into crash mode at any point of time. It might be because of lack of resources, or it might be because of some other reason. Or sometimes what we do is we will limit the resources on a Docker container. Because of that also, when the application tries to exceed that set limit, your containers will crash. But when we deploy the same container as a Kubernetes pod, does it offers any benefits compared to your normal containers? Let's check into that one. So that is my first question here. So just try to answer this and just try to figure out this answer. If you already have a Docker image and if you know how to containerize it, then why do we use Kubernetes pods? So this is the reason, people. Can you see here? The reason why we deploy containers inside a pod is they offer something called as shared networking storage, and shared storage also they'll offer. So what does it mean? Let's try to understand this, what a particular image. So if we have gone through the architecture of Kubernetes, we know that a pod will be created, and inside the pod, we will have what? Kubernetes, or inside this pod, we'll have containers. When these containers are running inside a pod, these containers can talk to one another by local host. That means since they are sharing a pod, they will share a network, as well as in case if you have something called a storage created inside a pod, the containers will share the same storage option also. That facility is available in your Kubernetes pod, right? That is one thing. And coming back to Kubernetes storage or persistent volume, we call it as, we will discuss about these things, PV, PVC, persistent volume and persistent volume claim in our further sessions. But in today's session, I'm just trying to explore what advantages Kubernetes pod offers compared to traditional Docker containers. So one thing what we understood is, if you have multiple containers inside a pod, right, they can form localhost or local net, and they can discuss or they can share the same network, and they can log in from one container to another container. That is one thing. And one more thing is, they will share the same storage option, right? This is the benefit that our Kubernetes pod offers. Because of that, we will be deploying our containers onto our Kubernetes pod, right? That is one thing. And if I have to look at a definition of Kubernetes pod, it says it is the smallest deployable unit inside a Kubernetes. Yes, that is true. That is the last part, or you can consider it as it is a last unit that will be deployed, right? Now, it says specifications for how to run a container. So basically, Kubernetes pod is the smallest deployable unit, and it offers some specifications for how to run a container. So it might be out of things, means you might not get what this thing is. So let me try to explain this with a particular example. See, just imagine, okay, before this, let me try to clear the screen. So if I have to look at a definition of Kubernetes pod, it says a pod is the smallest deployable unit in a Kubernetes. It specifies one more thing, that is, it provides specifications on how to run a containers. So what do you mean by that? So let me consider this with a particular example. Just you people tell me, how do you run a container? So generally the answer will be, we will use a command called as docker run, and what are the application we have. So we will use that particular command, we will run a container. In case if you have to create a volume inside a container, we'll use -v. In case if you're trying to map port, then we use -p options there. Yes, that is highly true. But so you have to run a proper container, or if you have to run this container, you have to write this command clearly. But Kubernetes pod says you can create a file, that is YAML file. We can create YAML file, and after creating a YAML file, you can write the entire specifications, that is what port to be mapped, what volume to be created, followed by what image to be used for creating a pod, as well as any other specifications we can specify in this one YAML file, right? And you can use this YAML file repetitively by just doing some sort of modifications. This facility that you don't get in your normal Docker containers. So that is one more advantages pod offers, right? And as I mentioned in the last, generally we run Kubernetes pod with single container. Why is that? I do have an answer for that one also. We'll get into the next slides. Alright people, so before I move into this one, so did I ask a question there? In the last slide, there was a question, that is, why do we use single container in one pod? Same question, once again I'm repeating here. Just imagine you are running 3 containers in one pod. There is one pod, there are 3 containers in this pod. But for some reason, the container is deleted. As I mentioned, it is ephemeral in nature. It has been terminated automatically. It had a memory leak or exceeds a memory limit. It can be any one of the reason causing it to be terminated. So the question is, if you had 3 containers in pod, out of which only one container is terminated. This is 1, 2 as well as 3. Out of 3 containers in one pod, one container is defective and it has already been terminated. So what will happen to other containers? Will they keep on running, or this entire pod is terminated? Just try to answer me in the comment section. So this is a scenario once again, let me explain. You have a pod inside which 3 containers are running, and for some reason you can consider it as what? Lack of resources. Automatically a container has been terminated. Only one container. What about the other 2 containers? Will they keep on running? Will Kubernetes recreate this container? How this thing works, let's try to understand in further sessions, but this is a question right now. So what you do is, you just comment it and let's try to understand how things work. Now, as I'm asked here, will the entire pod be replaced or terminated, or Kubernetes restarts or replaces failed container within the pod while the pod itself continues running? So what is the scenario? You just try to comment and explain it to me. Alright? Yes. Alright. So there is one more question. That is, see, in case of Docker, we saw if there is a container, imagine this is a container. Inside by using Docker, we have created this container. And we know that Docker network is responsible for assigning IP addresses to this container. Docker networking options. But if I have a pod, inside the pod, if I'm running container, who will assign, again, just hear me carefully. The question is, will container get IP address? If yes, who will assign IP for the container? If no, if pod gets an IP address, who will assign the IP to the pod? Just try to answer this question, right? So with this, we'll move on to next option. Alright people, let's check it. So once you answer this one, now let's move on to next option. That is, like I already answered this, specifications for how to run the containers. And I did mention that we will be creating a YAML file. We will be creating a YAML file for what purpose? To create a pod, and inside the pod we will be running what? Containers, right? And this YAML file is called as manifest file. Okay, so manifest file is nothing but your requirements, what and all your requirements. Either it can be, I need a particular port number to be opened, I need particular port to be mapped, or I need particular volume to be created. All these things you will mention inside this Kubernetes manifest file. All right, and this is what in the definition of pod was mentioned. Right, can you see? A Kubernetes manifest file is the core declarative configuration file. It is used to create and manage resources in Kubernetes cluster. So this is what I wanted to explain. Let me clarify it once again. A manifest file is a YAML file where a user will be writing down his requirements, like I need to create a pod, what should be the name of the pod, followed by, in case if he is trying to port map it, he'll mention that particular thing. In case if he's trying to create a volume, that also be mentioned. What image has to be used in creation of the pod, that also be mentioned in this manifest file. All right, people. So once we understood this manifest file, let's move on to next one. So this is a part of Kubernetes architecture, K8s architecture. I did mention about kubectl in our architecture, but once again, let me kind of revise that particular thing. Here's the thing, people. You are the user and you have written a manifest file that says I need a pod, right? And you have specified your requirements in this particular YAML file. It is written in YAML language. After this, you need to implement or execute this particular file inside your Kubernetes cluster. You need to execute or you need to send this file inside Kubernetes cluster so that this file will be read by API servers and read by your scheduler, controller, and they will take the necessary actions as well as etcd. All right, people. So for this purpose, we will take a help of kubectl. Can you see? It is a primary command line tool for interacting with Kubernetes cluster. At any point of time, if you're trying to create a pod, delete a pod, if you're trying to create any resources inside a Kubernetes, we will take a help of what here? Kubernetes kubectl. We will take help of kubectl. All right. Now, I hope you got once again clear-cut idea of what is kubectl, and we understood what is manifest file also. And I hope you have answered your questions. All right. So in the last session, we saw something about Minikube, but let me explain here. See, Minikube is a tool that will help me to create Kubernetes cluster. This is a tool that will help me to create a Kubernetes cluster. Right. So which sort of cluster? One master, one node cluster will be created by using Minikube, so that you can practice this thing locally. Right, that is the reason we have last class taken Kubernetes, in the last session we have taken Ubuntu server. There we have installed or we have created a Kubernetes cluster by using Minikube, right? So let's move ahead. Like I explained, Minikube will allow you to create one master, one node cluster that will helpful in practicing Kubernetes on your local system. So you can ask me, do we use this in production grade? No. For this, there are some other different tools. One such thing is kubeadm. Going further, I'll explain that particular thing also. We'll see how to set up a proper Kubernetes cluster going further. All right, people, as we discussed or as the heading mentions, let's try to create our first pod by using Kubernetes or by using Minikube. and let's check what advantages it offers, and let's check do we have any disadvantages of your Kubernetes pod. So let's check it practically how to create a Kubernetes pod and what are the problems that we face while creating a pod, or after creation, what sort of issues or what are the drawbacks that Kubernetes pod offers us. Let's deep dive. So for this, like I explained, we need to write Kubernetes manifest file called as pod manifest file. So for that, as you can see, I have just gone to Google and I searched for Kubernetes pod, and he will take me to official documentation of Kubernetes, where it has been clearly mentioned pods are smallest deployable units of computing that you can create and manage in Kubernetes. That is what I was explaining in my presentation. Now, so to create a pod, so here is your manifest or YAML file. So what I'll do is, so as you can see, there is an API version, what sort of kind we are creating pod, name, metadata for the pod, that is name for the pod, followed by name of the container, right? If I have to explain, as we saw in the diagram, where we had a pod inside which we had a container, and he is talking about name of that container, and in order to create that container, what image we'll be using. I'll be using Nginx, that is 1.14.2, that is a stable version of Nginx we'll be checking out. And directly we will be allowing port 80 to access from outside. Alright people, so what I'll do is, I'll just copy this one from here and let me move back onto my Ubuntu server where we have already set up our Minikube in our last session. So let's check it. You can use the command Minikube status. Alright people, as you can see, it says type is control plane, host is running, kubelet, API server, kubeconfig, everything is running. So in this place, what I'll do is, I'll just simply create pod.yml. The name of the file, you can choose it accordingly, but the extension should be either YML or YAML, both the things works here. Let me enter and I'll just paste in all the stuff. Let me verify. Let me take it up. Yep. Alright people, you can check it in this place. Once you copied the entire data of this pod.yml inside a server, you can just do cat and you can check whether the data has been completely copied or not. And thereafter, you can use a command called as, of course, once again you can observe here, I will be taking the help of kubectl for interacting with my Kubernetes cluster. So this is how I'll do it. Let me quickly install my kubectl. I don't think I had this one. Yep. -f. So the moment I execute this command, in the backend, the pod will be created. But before this, before I create a pod, what are the available details inside my cluster? Let me go and check it. For that, I'll use the command kubectl get pods -a. Alright people, as you can see, so I got etcd, I got API server, controller manager, proxy as well as scheduler, all the things are up and running. But there is no sign of something called as pod. Means there is no pod has been created yet because I haven't yet applied this particular file. And once again, let me go and let me apply this particular file, kubectl apply -f, and all these commands what I'm using here, we will be pinning this at the comments. As you can see, a pod has been created by the name Nginx. He says it has been clearly created. So let's go and let's check whether it has created or not. For this, you can use the simple command kubectl get pods -a. All right, people, you can see just a minute ago when I ran the same command, he clearly said that there was no such thing called as default or there was no such thing called as Nginx. But the moment I executed this file, already a pod has been created and it says running also. Right. So this is how you create a Kubernetes pod, and inside this pod our container is running. But how can we see where is the pod and where it is running? Right. For this, let me explain the architecture of Minikube, means how Minikube works there. Right. For this, let me take my presentation, Minikube. All right, people, just imagine this is my virtual machine which I have taken now. This is my virtual machine, that is EC2. And we know that for installation of Minikube, I need minimum 2 GB of RAM and 20 gigs of hard disk, and 2 CPUs. According to the same specifications, I have borrowed my EC2 server. And like I mentioned, Minikube offers one node, one master, or you can consider it as master as control plane. So this is my EC2. The moment I install Minikube inside this plan to create a cluster, this is what happened. A worker node got created here inside my Minikube. Of course, this part, or you can consider there as something called as control plane. This is node. And right now, when I executed my manifest file, that is pod.yml. So a container and a pod was created in this node. Correct? That means when I executed that particular file pod.yml, inside this node, it created what, my pod, and inside the pod, a container is created. And this container is of Nginx. So that means to check whether this pod as well as container is running or not, I need to enter this particular node. How can I do it? In order to enter this particular node, I will use a command called as Minikube SSH. Means I'm now trying to log in into this node by using SSH. All right, people. So let me enter this particular node. There I can show you whether this application is running or not. Right. For this, let me get inside my, which one? My cluster. Now, like I said, Minikube, if I do Minikube IP, can you see? This is my node IP. Like I explained that. So this is my node IP and I need to do Minikube SSH to enter inside this particular node. We'll come back with that one also. But right now, what I'll do is, before I enter into this place, if you want to check particular details about the pod, you can use this particular command also. Along with kubectl get pods -a, you can use one more command, kubectl get pods -o wide. Let me show you. And he clearly shows right now there is one pod which is status is running, and what is the IP of that pod? 10.244.0.3, and as you can see, it is running inside a node. The name of the node is Minikube. Right. This is what I was explaining. Of course, you might have entered the data or you might have executed the file, manifest file from your control plane, but the pod is created on your node called as Minikube. Right. So for this, we need to do what? Minikube SSH, or we will use direct Minikube or SSH into this particular IP. Let's go and check it this. When you do Minikube SSH, just observe here. Before I run Minikube SSH, it shows something called as Ubuntu and name of this particular server. Currently, this is the host ID of the private IP address of this server, or you can consider it as host name of this Linux. If I hit enter, sorry, alright people, can you see? I have entered into which place? My Minikube, or I have entered this particular node. So there I can use the command docker containers ls or the other commands related to Docker, and I'll be able to check whether the pod is running, and I'll be able to see the container which is running inside a pod. Let's go and check this one. So the first thing is I'll do docker -e. So as you can see, these many minutes ago, we have created a pod. We have created a pod, and this is the pod. Can you see? This is my pod, and this is my container which is running inside a pod particularly. You can see, K8s pod Nginx default. It is a pod which has been created, and inside this pod there is a container which is running. Perfect people. But can I access this pod? Or because we know that Nginx is a web server, by default Nginx will have something called as welcome to Nginx page. Can we access that particular page right now? Yes, let's check how to access this particular page. But before this, let me exit from this particular Minikube node. If I hit exit, I'll be completely exiting this particular node. Now, to access the content of a pod, we need to know the IP address of the pod. For that purpose, what I need to do is, I need to know the IP address of the pod. How can I know the IP address of the pod? Let's go and check it. kubectl get pod -o wide. Can you see? This is my IP address of the pod, not a container. So I did ask you guys question in the beginning. So this will sum up the answer. Please go through this one. Just try to relate the question with the answer. We'll try to move on from here. Now, if somehow I use curl command and use this particular IP address, I should be able to see the contents of a pod. But in order to access the contents of the pod, I should be entering inside the Minikube node. How to do it? It's again same thing. Kube SSH. Once I'm here, I'll run a command curl -l http. Oh, great. .244.0.3. Alright people, as you can see, this is my HTML page. Welcome to Nginx. Right. And it says, if you see this page, the Nginx web server is successfully installed and working. Yeah. That means inside my node of a Minikube, inside that I have created a pod, and inside this pod I am running a particular container of Nginx, and this justifies that pod has, or pod is running a container. All right. So you people might have a question. The question is, why do I have to enter the node every time to access this application? Right? If that is the case, then the whole point of using Kubernetes, right, it is completely gone. And so I'm gonna give access to a cluster for a user, normal user who's trying to access your Kubernetes cluster from outside. I'm gonna give him the access to the cluster or a particular IP address to access your pods. No, that is not possible. So what is the solution for this one? Yes, we do have a thing called as ingress service kind of stuff. We will check this thing in further sessions. But as of now, our main focus is, so in this session, this is what we have done is, we deployed an pod, and inside the pod, we had a container, and inside this container, or the container is running this application. All right, people? So this was the thing. But before I move ahead, okay. All right, before I move ahead, let me sum up what we learned in this session. All right, people. So this is what we saw in this particular session. We saw how to create a pod by using manifest file. That was our main aim, and we understood what is manifest file. We understood what is Minikube, how the architecture of Minikube works. Along with that, what are the drawbacks that we have in normal containers? Means in case if you're trying to deploy your Docker image as a normal container, so what problems you will face? We saw all those things. Then we move ahead with this particular thing of pod. But the question is, has the Kubernetes pod solved the issues of traditional containerization? Let me check it. All right, people, let's try to understand the difference between normal containers as well as pod. As we know, containers are ephemeral in nature. Because of that, they might crash. Right? And to overcome this thing, we came up with a solution called as pod. But has the pod actually solved the issue of traditional containerization? No. See, what we were looking is, in case if the container is deleted, we needed to auto heal this pod or this container. Whenever the container is crashed because of lack of resources or limits kind of stuff, it should be auto healed. This is what we were looking. When I say auto healed, this container should be replaced immediately. So has pod been able to deliver such sort of things? Let's check it right now. What I'll do is, anyhow, I have a pod. Let me go back. Let me delete this particular pod. Let's check, will Kubernetes recreate this particular pod or not? All right, people, as you see, I have come out of this Minikube, and what I'll do is, I'll check all the pods and let me copy the name of the pod, that is Nginx. The command what I'll run is what did I do? kubectl delete pod Nginx. This is used for what? Deleting the pod. According to traditional containerization, what happens? If the container is deleted, they cannot be replaced or they won't be replaced. So for that reason, what we did, we went into Kubernetes pod. So let's check the moment of truth. Has Kubernetes delivered what it promised? Oh. Can you see? I deleted a pod which was Nginx. Has it deleted? It has been deleted, you can see. But has a new pod been created, or has the Kubernetes created a new pod in that particular space, or is it replaced? No, it has not replaced. That means normal Kubernetes pod is still not be able to overcome the drawbacks of traditional containerization, right? So the only thing the pod has solved here is it provides shared networking, shared storage access. That is the only thing it does. So let's try to understand what or how we can solve this particular issue. That is, we need to have an auto healing solution. For that purpose, let's check what new method or new things that we can implement so that we can have an auto healing facility. If this session has helped you learn about Kubernetes, do hit like, share and subscribe button for Star Ajay. I will meet you in the next video. Till then, keep learning.